Welcome students, welcome to expert tutorial. Today we'll discuss about a chapter force and motion. So first we have to answer what is force. Now force is basically an external agent that is capable of changing a body's state of rest or motion. In other words, we can say that the force is an external effort in the form of push or pull. But what are the effects of the force? So there are various effects, that is, the force can make a body that is at rest to move. That is like this. You can check the picture. That is, you can change this body from rest to motion. It can stop a moving body or slow it down. So it can, by applying the force, you can stop a moving body or you can slow it down. It can accelerate the speed of a moving body. You can see, you can accelerate the speed of a ball by using the bat or by using the force through this bat. And it can also change the direction of a moving body. That is, you can also check that you can change the direction of the ball by applying the force by using this bat. And you can change its shape and size. So these are various effects of the force. So you can change the shape and size of the body by using the force. So these are some effects of the forces. Now Newton's laws of motion, the famous Newton's laws of motion. So Sir Isaac Newton in his book Principia published 3 laws of motion related to all moving objects in the universe. So these are known as the Newton's laws of motion. These laws cannot be proved using any old concept of physics, yet their validity can be confirmed through successful explanations and predictions on numerous events in nature. So Newton's first law. So it states that a body at rest or uniform motion will continue to be at rest or uniform motion until and unless a net external force acts on it. So this first law of motion, it is also known as the law of inertia. We get the concept of inertia from the first law. Now the question arises, what is inertia? So the first law that leads to the idea that the natural tendency of any body at rest is to remain at rest, or the natural tendency of a moving body is to continue to be in a state of uniform motion. So in both the cases, the body cannot change its state by itself. So this natural tendency of the body to resist any change in its state of rest or state of motion is known as the inertia of the body. So this tendency of the body to oppose any change in its state of rest or uniform motion is called the inertia. Now inertia can be either inertia of rest or inertia of motion. So what is the inertia of rest? So inertia of rest is the tendency of a body to remain in the state of rest. Now here is an example of inertia of rest. So this is basically a very simple example, simple experiment you can do at your home. A postcard is kept on the top of a glass and a coin is placed on the postcard. So when the postcard is given a sudden horizontal flick by using the finger, it flies up sideways, and the coin, due to the inertia of rest, drops into the glass. So this is a beautiful example. You can do it yourself at your home. So this is basically an example of inertia of rest. Now coming to the inertia of motion. So the tendency of a body to remain in its state of uniform motion, it is the inertia of motion. So This is basically an inertia motion. So when a moving vehicle, it was a moving vehicle. So when a moving vehicle suddenly applies brakes, passengers lean forward or fall. They were in motion with the vehicle, but when it suddenly applies brakes, their lower limbs, that is, their lower limbs being in contact with the vehicle, slow down, but the upper parts of their bodies continue to move in the forward direction, and that's why they lean in the forward direction or fall. So this is also an example of the inertia of motion. Now coming to the concept of inertia and mass. This is very interesting and very important concept. So a body at rest continues to be at rest, and a body in motion continues to be in motion. So this property of the body is called the inertia. Now the inertia of a body is measured by the magnitude of the force required to change the state of the body. Now we all know that the force required to change the state of a heavier body is more than the force required to change the state of the lighter body. So this is because the mass of the heavier body is more than the mass of the lighter body. So you can say that the mass of a body is a measure of its inertia. So this is very important thing that you should remember, that the mass is basically a measure of its inertia. Now, coming to Newton's second law of motion, it states that the rate of change of momentum of an object is proportional to the applied force in the direction of the force. Uh, now, uh, you can derive the now coming to the mathematical expression of the second law. Suppose a body, suppose here is a body, and just a moment. Suppose here is a body and it was moving with initial velocity u, uh, and after application of the force for some time t, its velocity gets changed to v, and the force was applied for a time t. So the initial velocity is u and the final velocity is v, and by using the relation u v equals to u plus at, where a is the acceleration, so acceleration of the body a equals to v minus u by t. We all know that this acceleration is nothing but the rate of change of velocity, so acceleration a equals to v minus u by t. So now according to this Newton's second law, the rate of change of momentum, so the rate of change of momentum equals to mv minus mu by t. That means m into v minus u by t, and this v minus u by t is nothing but a, that is acceleration. So the rate of change of momentum is equals to m into a, mass into acceleration. Now from Newton's second law, F, that is applied force, is proportional to m into a, this rate of change of momentum. Or you can say that this F equals to k into ma, where k is the constant, And this is a situation where we are free to define a unit of force. Now by convention, it is defined in such a way that the proportionality constant becomes unity, that is if k equals to 1 for m equals to 1 and a equals to 1. If we put f equals to 1, then this k will be equals to 1. So we got the equation by using the putting the value of k, that is f equals to m into a, and that is the force equals to mass into acceleration. And this equation is called the law of motion of a body of constant mass. So this is very important equation. And now coming to Newton's third law of motion. So this third law of motion states that to every action there is an equal and opposite reaction, and they act on two different bodies. So this statement is very important, that is to every action there is an equal and opposite reaction and they act on two different bodies. So action and reaction never acts on two same body. So take an example, that is when a bullet is fired from a pistol or gun, it exerts a forward force that is known as the action. This is the action on the bullet, and the bullet exerts an equal and opposite force on the gun, that is known as the reaction, and the gun recoils. Basically it moves in the backward direction, that is known as the recoil of the gun. So this is basically the example of the action and reaction. And also you can take the example of a sailor, that is when a sailor jumps out of a boat, he exerts a backward force of the boat, that is action, and the boat exerts an equal and opposite force on the sailor, that is the reaction, and the sailor jumps forward. So this is also an example of the Newton's third law, that is action and reaction. Now coming to a very important topic, that is impulse of force and impulsive force. So impulse of a force, it is basically the product of a force and the interval of time for which the force acts on the body. So this impulse equals to, so this impulse I equals to force multiplied by the time of action, and its SI unit should be Newton second. This SI unit should be Newton second. Now the relation between impulse and linear momentum is that we all know that this impulse equals to force into time. So impulse equals to F into t, and this F is nothing but mass into acceleration, that is mass into v minus u by t into t. So it will become m into v minus u, that is change in the linear momentum. So the impulse becomes the change in the linear momentum. Now coming to the impulsive force. So impulsive force, basically a large amount of force acting on a body for a very small interval of time is known as the impulsive force. Example, that is the striking of cricket ball by a bat. Here you know that we all know that this the striking of cricket ball, these are very huge forces, but it acts on the ball for a very small interval of time. So that is the impulsive force. And also the hammering on a nail, it is also an example. That is a huge forces acts for a very small interval of time. It is also an example of impulsive forces. So thank you everybody.